Okay, so I have another example that uses parallel arrays. This one deals with attractions at Disneyland in California. And so we have the attractions array with 10 rides. And again, just like in the last example, I padded them with some trailing blanks just to make things easier when we print them out and line them up in columns. So we have the rides, indexes 1 through 10, and then the various wait times for these rides in the wait times array. Okay, and again, I had to be very careful to make sure I got the appropriate number of minutes wait time with the appropriate ride. So Pirates of the Caribbean is the first one in the attractions array, and so that's a 15-minute wait. I'm making sure that's the first one in the wait times array. Haunted Mansion is the second one in the attractions array, and then the 13 minutes, they usually do that just to be funny with the 13-minute wait time. That is the second one in the wait time array. So I made sure everything matched, okay? So then I have some column headers, and as we were talking about in the previous videos, you can loop through the arrays in parallel, okay? And it really is just a matter of referencing both arrays in the text window.WriteLine statement. I'll just throw both arrays in there. I did, you know what, I really cheated here, like with the spacing, just to not have to worry about the tabs and all that. So I have, I just eyeballed it and made enough spaces so that it looks nice and all lined up like that. Okay, so that's the lining up is not the important part. The techniques, the looping through in parallel, the loop counter, which is Z in this case. I like to mix it up. Z is the loop counter, so I'm using that loop counter as array index. So what I want to do in this example is show you how to get an average. What if I wanted to display the average wait time for all these 10 rides at Disneyland? What would I have to do? I mean, if I asked you to do it with a calculator, you could do it very easily. You would just add them all up and then divide by 10, right? So our program can do that just as easily, more easily. And here's what we'll do. We are going to, here's a technique. We'll create a variable. Let's call it running total. Okay, and we're going to initialize it to a nice clean 0. And inside of our loop, now that was outside of the loop. Before I dove into the loop here, I have this running total variable. And now inside of the loop, it doesn't really matter where, I am going to say running total equals whatever's already in there, running total, whatever happens to be in there, plus the wait time that I'm currently looking at in this iteration of the loop, which I can access through wait times Z. Again, loop counter as array index. What is happening here? Okay, let's say, here, hang on, this is going to be my running total variable. Let's pretend this is my running total variable in memory, and it starts at 0, okay? Starts at 0. First time through the loop, I'm saying running total is going to be equal to whatever's already in there, 0, plus the wait time that I'm currently looking at, which is 15 first time through. It's the Pirates of the Caribbean, right? 15 minutes. So 0 plus 15 equals 15. Okay, that was the first time through the loop. Second time through the loop, running total equals whatever's already in there, 15, plus what I'm looking at currently. This is the second time through the loop, so I'm looking at 13. 15 plus 13 is 28. Okay, that was the second time through the loop. Third time through the loop, running total equals whatever's already in there, 28, plus whatever wait time I'm currently looking at. Now we're looking at the Space Mountain, which is 60 minutes. So 28 plus 60 is 88. Okay, so do you see how the total keeps growing and growing? And as we get to the bottom of the loop, then I will have added up all of those values. So really the last thing to do when it's all said and done is to divide, maybe say AVG wait time, AVG wait equals running total divided by, I can hard code a 10 here. We know there are 10 rides, or a better way would be this guy, our array get item count. Then if I add more rides, for example, or take some away, I don't have to worry about fiddling with this and fiddling with my loop. So yeah, that's really the better way to do it, even though it's more typing. Okay, so why don't we display our total, make sure it works. We'll say text window. You know what, how about maybe a couple of blank lines? You can do that just by putting a null string in there. Okay, so now maybe on this third one I'll say average wait time. Maybe do something new here, like a little arrow or something. And I'll concatenate the AVG weight that I calculated. And then maybe I'll say minutes as well, so the user knows what we're looking at. Okay, let's run it. We'll see how it goes. Okay, that looks pretty good, actually. The average wait time is 33.8 minutes. It sounds about right. So there you have it. Getting a running total, or this is also called getting an accumulative total. Okay. Accumulative total. Very common thing to want to do in programming. This thing here, the whatever's already in there thing, that spiel, and having that variable on both sides of the equal sign. Okay, running total is really what we would call an accumulator variable, because it serves that very specific purpose, is getting that accumulation of all the values, and then finally at the end we'll divide it by the number of items. Okay.